All right, guys, we're nearly there. So this is the last question and the last video of this series of hypothesis testing that you need to be aware of. And if you can answer this question here, then that's it. We completed the set for hypothesis testing questions. So this question says, over a long period of time, it has been found that Enrico's restaurant, the ratio of non-vegetarian to vegetarian, so the ratio of non-vegetarian to vegetarian is 2 to 1. In manual restaurants, in a random sample of 10 people ordering, one ordered a vegetarian meal. Using 5% significant level, test whether or not the proportion of eating vegetarian meals in manual restaurant is different to that in Enrico's restaurant. So this question is a two-tailed question because it does not tell us if it's going to be greater than, if it's going to be less than, if there's an improvement, or if it's not an improvement. So therefore, this is where we have to apply the two-tailed test. So now what we need to do is need to create our hypothesis and then use that in this case here. So if I start with that, so my hypothesis is going to be what? So I can say that X is binomially distributed with my N being 10 people. So my N is 10 and comma P because I don't know what P is at the moment. So the null hypothesis, I can say that my null hypothesis, my P value is going to be equal to 0 or 1/3. Why we come up with 1/3? The ratio is 2 to 1, so you add up the values and then you compare we're focusing on the vegetarian, so it'll be 1 out of 3 people. And the alternative hypothesis is where P is not equal to 1/3 because we don't know if it's going to be greater than, if it's going to be less than. So therefore we say not equal to 1/3. And this is where the question becomes a two-tailed question. So we need to have a look on how we can answer it. So again, we can use the method 1, which is finding the probability using the X value that they provided us. So we can see that the 1 is going to fall under the lower side of it. So, and therefore we can find the probability that X is going to be less than or equal to 1. And if you do that for that, put in a calculator with these values, that gives us an answer of 0.104. And this is the answer that we get, and we can clearly see that 0.104 is greater than, because remember guys, it's 5% significant level, but because two-tailed test, we have to half it. So 5% divided by 2 gives us 2.5%, which is equivalent to 0.025. So 0.104 is greater than the 0.025. And what does that mean in this case here? That we can say clearly there is no evidence to reject H naught, and therefore there is no evidence that portion of vegetarian or veg meals and manuals is different to Enrico. And that is it, guys. This is using the method 1, which is the most simplest way to do it and to prove it. So now let's have a look on how we can do using method 2. Method 2, remember guys, is finding the critical region. So we can have a look at method 2 and see how the method 2 works. But let's do a small little diagram to visualize it. So method 2 is we're finding the critical region on either side. So we're finding the critical value 1 and the critical value 2. And therefore, if it falls under here, there's below that, or if it falls under that top part, we know that this is the part that we reject H naught, okay? So here we reject H naught, reject H naught. So let's have a look on what we need to do in this case here. Again, for two-tailed tests, remember that we're not trying to find the value that is below the significant level, but the closest value, the closest number that we can get to the critical value. So let's do it for the lower tail. So for the lower tail, what we need to do, we need to test different values. So let's try to do with x is less than or equal to 1. If it's less than or equal to 1, therefore what we can see that it gives us a value of 0.104. If you use a calculator, put x is equal to 1, p is 1/3, and is equal to 10, gives us 0.104, which is very close to the 0.025, but let's see if there's a number that can get even closer to it. Let's try a lower number because this is bigger than 0.025. So let's start with x less than or equal to 0. So if you do that in a calculator, put that in a calculator, that gives us a value of 0.017341. And we can see that the probability when x is less than or equal to 0 is much, much closer to the 0.025. And therefore, we know that our critical value for the lower side is going to be x equal to 0. So in this case here, we can say that x equal to 0. So that's what a critical value, in this case here, the bottom part becomes. So now we have to repeat the same process for the upper tail. So for the upper tail, in this case here, we're trying to find the probability. Again, you can test and trial with some values. In this case, let's try it with some upper values. So x is greater than or equal to 6. And if we do that, that gives us 1 minus probability that x is less than or equal to 5. And if you put this in a calculator, that gives you a value of 0.07656. And if we do probability that x is greater than or equal to 7, to check if there's another value that can get closer, x is less than or equal to 6. And therefore, that gives us a value of 0.01966. And we can see that between the two values, the number that is the closest to that we want is when x is greater than or equal to 7. And therefore, this is the closest number to the 0.025. Therefore, what does that mean? My lower value here, my critical value here is 0 for the bottom part. And for the upper part, my critical value is equal to 7. So if I find a value of x that is greater than 7 or value of x that is less than 0, then that falls in my critical region and therefore I reject H0. However, in this case here, 1 does not fall into the critical region. Therefore, 1 falls under the safe region, which is going to be this section here, right? We can say that it falls under the safe section, which is this part here. So therefore, we do not reject H0. There is no evidence to reject H0, and there is no evidence that the proportion of vegetarian meals at Emmanuel's is different than Enrico's. And that will be our final answer for this question here. Hopefully you find this series useful. So this is all your whole hypothesis testing completed. I went through the examples, going through the main test cases. But hopefully you find this useful, and let me know if you find it useful. Then I will do more videos on just hypothesis testing in general from exam questions. All right, thank you.